We're back in Spain. Yes, we are now going to apply this thinking about area to the area of this circular plaza. So let's go back. I'm going to just keep harping on these measurement strategies, or this three-part process to measurement. So number one, hey, measure that circular plaza. Well, what about it do you want me to measure? Do you want to measure its circumference? We've already done that. Or do you want to measure its area? Well, this time we're going to measure its area. Number two, find something else that has the attribute of area. Now, as we did with the circumference of the circle, we used its radius length and said how many copies of the radius length did it take to span the entire circumference of the circle. This time, to measure the area, we need something else that has the attribute of area. A two-dimensional measuring device. How about this? Imagine a square that's 1 radius by 1 radius square. Okay, stop imagining. I'll just show it to you. Here is such a square. This square is 1 radius in length this way and 1 radius in length this way. Thus, we call this square a 1 square radius length. So the question in measurement then is, okay, we want to measure the area of the circle. Number two, we're going to find something else that has the attribute of area. Hey, how about a square radius? And then number three, compare multiplicatively. That is, how many of these square radii would it take to fill in this circle? No gaps, no overlaps. Now you might be thinking, why are you trying to put a square peg in the round hole? Well, because that's what we do. An area measurement is a square unit measurement conventionally. And so we're going to use the convenience of the radius of the circle as our measuring device and ask the question, how many square radius lengths would fit inside of the circle? So I would argue so far, the area of this circle is more than 1 square radius. How about 2? That's more than 2. 3? Now remember, this is a circle, and so we're cutting off the corners of these squares a little bit. So would those extra corners all fit in this space right here? So maybe it's 3. 4 is probably too much. Notice that the circle is in here, and so we've got extra space. So I'm going to argue that the area of this circle is not 4. I hope you can see now the extra space out here. So we're going to say that the area is less than 4 radius squares. Notice, as you saw in the video before, this exponent notation to say 4 copies of a square radius. The area of this circle is less than that. Well, what is it then? Well, would it be okay with you, just in estimation strategy here? I don't mean this to be super precise, but just as an estimation, I'm going to say that this circle, or this quarter of a circle, covers up about 3/4 of this square. That is, 3/4 of the square is in here, and 1/4 of the square is out here. So instead of saying that the area is 1 square radius, I'm going to say the area is 3/4 of a square radius, and another 3/4. 3/4 and 3/4 would be 6/4. 9/4. 12/4. 12/4. 3, 6, 9, 12/4. I'm going to say that it's probably more like around 12/4. Now, 12 1/4, since 4 1/4 makes a whole, 12 1/4 would be 3. I'm going to now argue that the area, it's less than 4 square radiuses, and I'm going to say it's closer to 3 square radiuses. Now, as you've seen with perimeter, if I actually knew what the radius was, you actually do, it was 122 feet, we would just say 122 times 122, and then we've got about 3 of them. So whatever 3 times 122 times 122 is, would be the area in square feet of this circle, roughly. Now, to be more precise, to see what it really is, check this out. Now, this is going away from the plaza in Spain. This is just another context. This is just a visual to help you to see that the 4 square radiuses was too big. The 3 square radiuses was probably closer. But can we get even closer? All right, watch this. If I took this circle and cut it up like a pizza into 1, 2, 3, 4, 5, 6, 7, 8 slices. And I took those slices and I rearranged them. Like imagine an 8-slice pizza, and you put a slice here, and you put a slice here, and 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 a slice here. Can you use your imagination and pretend it was flat across here and straight down here? This thing is, at least roughly speaking, rectangular in shape. Now, what you're going to see is later on, instead of 8-slice pizza, imagine I slice this pizza up into 80, 800, 8,000, 8 million slices. Really tiny pizza slice wedges. Then, when we arrange those slices like this, it would look more and more like a rectangle. You'll see that later. But it looks more and more like a rectangle, and as you've seen, the area of a rectangle is the base of the rectangle times the height of the rectangle. Now let's talk about that for a minute. The base of a rectangle. Now, it doesn't matter if I look at the top or the bottom. I'll look at the bottom just for pointing purposes. Can you see that the base of the rectangle is this, 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 and this? It's those 4 outer edges, like the pizza crust. It's those 4 pizza crusts. Those 4 pizza crusts, when they were in here, were part of the circumference of the circle. But the yellow pizza crusts are only half the circumference of the circle, the other half being these maroon pizza crusts. So back to here, when we think about the base of this rectangle, or nearly rectangle, the base is just the yellow crusts, thus is half the circumference of the rectangle. Of the circle, sorry. The height of the rectangle is this. Now, can you see that the height of the rectangle corresponds to the radius of the circle? Let me go back to the circle again. I was just trying to show you that if I was to rearrange these into almost a rectangular form, the height of the rectangle would be this distance right here, which corresponds to the radius of the circle. So, we could say that the area of this rectangle is the base times the height, but the height is the radius of the circle. And the base is half the circumference. Now, we already know that the circumference is 2 pi copies of a radius, 2 pi r. But we only have half. Remember, just the yellow is only half the circumference. Now, I hope you can see just a little bit of like computational algebraic type thinking here. Half of 2 pi r would be 1 pi r. In other words, half the circumference would just be, instead of 2 pi r, would just be 1 pi r. And then I hope you can see that radius multiplied by radius is radius squared. The area of a circle is less than 4, around 3 pi r squared. Pi copies of a radius squared. Now let me just jump back here really quick and make the connection. we were looking at this and saying, how many copies of this square radius would it take to fill up the circle? We said 1, 2, 3, 4 was too many. So we ballparked it and said it's about 3/4 of a square. So 3, 6, 9, 12 fourths. 3r squared. Just ballparking it, estimating it. From this, we can see that it's actually just a little bit more than 3r squared. It's pi r squared. Remember, pi is 3.14 approximately. Yeah, the area of a circle, pi copies of r squared. Around 3, a little more, copies of a radius square could be tiled inside of that circle. No gaps, no overlaps. Now, I wanted to show you this image just so you could see why we're talking about rectangles. The more slices you have, the skinnier the slices would be. And as you organize them, reorganize them into this rectangular shape, we can sort of turn a circle into a rectangle. And the area of a rectangle is the base times the height. The base is half the circumference. The height is the radius. And so we end up with this line of reasoning. Half the circumference times the radius. Circumference is 2 pi times 2 pi copies of a radius. Half of 2 pi is 1 pi. Radius times radius. Radius squared. But then we just simplify this and say pi r squared. Yeah, the area of a circle is pi r squared. Isn't that awesome? Take that and see what you can do with it in the next assignment.